Hello, geometry, and welcome to lesson 3. We're going to be doing, like I said in lesson 2, word problems. So don't freak out with these. They kind of all follow the same basic pattern. And learning targets, I can differentiate between an angle of depression and an angle of elevation. And I can accurately set up and solve word problems involving trig. So we're going to focus right away on angles of depression and angles of elevation. So this picture is going to help us with that. So here we go. So in the picture above, angle 1, right here, represents an angle of depression, specifically from the mountain or mountaintop to the hiker or the person. Angle 2 represents an angle of elevation, from the hiker, basically backwards here, to the mountain. Okay, now let's look at the other ones, 3 and 4. The angle of elevation from the cabin to the person is represented by angle 4. And then the angle of depression from the person to the cabin is the opposite direction. It's angle 3. Now, you see some dotted lines in there, right? Those are very, very important. The dotted lines are all horizontal, which means they're all horizontal, they are all parallel. And because they are parallel, I can say that angle 1 is equal to angle 2, and angle 3 is equal to angle 4 because of alternate interior angles theorem, which is a first semester thing that we've learned, hopefully. Okay, if I have parallel lines cut by a transversal, then alternate interior angles are congruent. So 1 and 2 are equal, 3 and 4 are equal. Okay, that's going to always be the case with these problems. The angle of elevation equals the angle of depression. Now, we have 5 word problems to play with. We're going to draw the situation, and then we're going to solve it. A pilot sees a life raft at a 26-degree angle of depression. If the pilot's altitude, or distance above the ground, is 3,000 meters, what is the plane's actual distance to the life raft, to the nearest meter? So we've got this plane. Again, don't spend a bunch of time drawing. And you got this life raft down here. Okay, water, right? The plane is 3,000 meters above the water. So that right there is 3,000 meters. And the distance from the plane to the life raft is what we're looking for. It says that it has a 26-degree angle of depression. Now, here's what a lot of people will want to do. They want to put that angle of depression right there. And I'm going to tell you over and over again, don't. The angle of depression always is formed by a horizontal line. That 26 where I just put it, that's formed by a vertical line and the diagonal line. Never, 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 never. The horizontal line isn't there right now, but I could draw it. That's where those dotted lines come in. That dotted line is an imaginary line, but it's horizontal. From that dotted line to the diagonal line is 26 degrees. That's the angle of depression. Now you might be like, well, that's not even in the triangle. You're right. But that's why we talked about why alternate interior angles are so important in this situation, because this down here is then 26 degrees. That's the alternate interior angle from that angle of depression up at the top. Now I've got a triangle, a right triangle with 2 sides and an angle. What do I use here? Well, I've got opposite and hypotenuse. I'm going to be doing sine of 26. Opposite is 3,000. X is over X. I know I've talked about this one before, so I'm not going to spend a bunch of time on it. I'm going to multiply by the denominator. Sine 26 equals 3,000, and then divide by sine 26. So I'm going to go ahead and do that in the calculator. 3,000 divided by sine of 26 gives me 6 6,843.5. And it said to the nearest meter, so 6,844 meters. That's how far the plane is from the life raft. Okay. On to the back page. This one adds a little bit to it. Number 2 does. A surveyor stands 200 feet from the base or from a building to measure its height with a 5-foot surveying tool. So someone's standing back here with this tool, and they are 200 feet from this building. Now look how I'm drawing this. I want to show you something that's happening here. The tool is 5 feet tall. We are 200 feet from the building. We want to know how tall the building is. Well, with the way the triangle is set up, we're missing 5 feet here, right? Because that triangle is, the bottom of that triangle is 5 feet above the ground with the way it's drawn. So what I'm going to have to do at the end is I'm going to have to add 5 to my answer. So I like to do that before I even do the problem, because that reminds me I need to add 5 to my answer at the end. Okay. Let's get an angle in there. The angle of elevation from the top of the tool to the top of the building is 35 degrees. So that would be here. Which trig function am I using? You should know this by now. We are using tangent of 35, and that equals x over 200. Multiply by 200, I get 200 tangent 35, and I get 140.04, which nears 1/10 of a foot, so 140.0. But I got to remember to add the 5 in there at the end, so the building is actually 145.0 feet tall. Okay. Example 3. A ship is able to determine that it is 600 yards from a sunken ship. So this time, we've got water up here. We got a ship. It's 600 yards from a sunken ship. So something down here crashed, right? We are 600 yards away. Direct line. If the angle of depression to the sunken ship is 50 degrees, how far does the ship have to travel to be directly over the sunken ship? So we want to know how far it has to travel to be directly over it. The angle of depression is from the horizontal line, which is actually drawn here. So that angle right there is 50, which is actually inside the triangle, which is good. So I've got the hypotenuse is 600, and I've got the adjacent side is x. So it's going to be cosine. So the cosine of 50 equals x over 600. Multiply by 600, I get 385.67. It says to the nearest yard, so 386. It has to go 386 yards to be directly over the sunken ship. Okay. 2 more. It's number 4 and 5 are a little tricky, but some of these can be. So I want to show them to you in the notes. The Americans with Disabilities Act states that a wheelchair ramp can have a slope no greater than 1/12. Okay, so we've got a ramp for wheelchairs. A slope of 1/12 means rise over run. Well, the rise can't be 1, and the run is 12. Right? Doesn't matter what it's measured in, 1 foot over 12 feet or 1 yard over 12 yards. It's all going to reduce down to 1/12. What is the biggest angle of elevation of a ramp with this slope? So we're looking for the angle of elevation. Looking for an angle this time. So opposite over adjacent, we're looking at tangent of x equals 1/12. So x equals the inverse tangent of 1/12. Type that in your calculator, you get 4.76, right? Now, a lot of people take this and round, it says to the nearest 10th, and they'll say 4.8, right? Because 4.8 would be the rounding rules here. However, if I round this up, it's actually going to be a little bit higher of a slope than what's allowed by the law. So I actually can't follow rounding rules here. I can't go up at all. I've got to go back to 4.7 to follow the law, basically. So 4.7 degrees is what that angle of elevation can be at maximum. All right, last one. Definitely has a little bit of a trick to it here. A pilot is descending towards a runway at a 3-degree angle of depression. So again, we got our plane here. His current altitude is 2,714 feet above sea level. If the runway is 1,007 feet above sea level, so the runway is not on the ground. The runway is actually, well, it is on the ground, but above sea level is, yeah, an imaginary level. So this is actually on the ground, but the ground is actually 1,007 feet above sea level. So this is 1,007. So how high is the plane above the runway? You got to do 2,714 minus 1,007, and you get 1,707. So this distance here is 1,707 feet. Okay, and we want to know how many miles. So miles is going to be a key here. Right now we're in feet, but I got to change to miles. Is the plane from the runway. So we're looking for that. It's a 3-degree angle of depression. Again, you do not want to put the 3 here. That's bad. Don't do that. Horizontal line. This is 3 degrees, which means this is 3 degrees. So I have opposite and hypotenuse. This is sine of 3 equals 1,707 divided by x. I get x sine 3 equals 1,707. Divide by sine 3. So I get 1,707 divided by sine of 3, which is going to give me a very big number, 32,616.2. But that's feet. I want to know how many miles that is. So divide that answer by 5,280, because that's how many feet are in a mile. And I get 6.18. It's 6.18 miles from the runway at the current spot. Okay. And that is word problems, which they're all, like I said, they're all going to kind of follow the same basic pattern. Not too difficult if you practice. So that's it.